Good day, I'm Zach. This is my sprite which allows me to easily point out examples. To easily present some algebraic expressions will be represented by alphabets. Y equals x to the power 2 will be represented by y equals to j, and y equals ax to the power 2 plus bx plus c will be represented by y equals to z. This presentation is to explain the relationship between y equals to j and y equals to z. Firstly, it is shown that x ranges from -5 to 5, then y value is shown for the range of x when the numerical interval is by an integer of 1. As you can see, y equals to j where y is the square of x. Secondly, the input of b and c is shown here and here respectively. Once the values have been added, the table here shows the output of y when y equals to z when x is -5 to 5. Here is the Excel formula I used to automatically give the y value. Thirdly, we can see the graph of y equals to j and y equals to z superimposed. This enables us to easily see the differences between y equals to j and y equals to z when the values of b and c change. The orange line represents the y equals to z graph, while the blue line represents the y equals to j graph. Fourthly, here are the numerical discriminants for y equals to z. Additionally, I have also written the formula to find the discriminant value here, and here is the Excel formula used. Below that is the solution of the equation y equals to z when x is made the subject. Here are the Excel formulas that I used to get the x values. It is a quadratic formula, by the way. Fifthly, let's start with the fact that z can be reconfigured to become bracket x plus b over 2 bracket to the power of 2 plus c minus b to the power of 2 over 4, which I will represent as O in the completed square form. It is extremely similar to the y equals to j equation. What would happen if b is increased? It will affect the bracket x plus b over 2 bracket to the power of 2 represented by p, and the bracket c minus b to the power of 2 over 4 bracket represented by I part, right? Let's see what happens to the p first. Obviously, if b is increased, the value of p will increase. Conversely, if b is decreased, the value of p will decrease. Now that we know that the value of p will change depending on b, what happened to the y equals to O graph when we change the b value? Well, let's see. If b equals to 6, the graph will shift 3 units to the left from the original y to j graph, and if b equals to 3, the graph will shift 1.5 units to the left from the original y to j graph. We can see that when b decreases, the graph will shift to the right from the original y to j graph, and when b increases, the graph will shift to the left. This is extremely similar to y to j, as if one were to do addition to x before it gets squared, the graph will shift to the left as shown here. Now when b changes, I will also change. If b increases, then I will decrease. Oppositely, if b decreases, then I will increase. Now that we know that I will change when b changes, let's see how the graph changes. If c equals to 0 and b equals to 4, the graph will shift forward 4 units downwards from the original y equals j graph. If c equals to 0 and b equals to 8, the graph will shift 16 units downwards from the original y equals j graph. Therefore, when b increases, the graph will shift downwards. Conversely, when b decreases, the graph will shift upwards. Why does the graph shift like that? If y equals to j has additional subtraction, then the value of y will always be affected. For example, let's superimpose y equals to j and y equals to j plus 1. For all values of x, the value of y for the corresponding x value for y equals to j plus 1 will always be 1 greater. Therefore, the additional 1 is similar to I in the nature of how it affects the graph. Additionally, when c changes, I will also change. When c increases, I will increase, and vice versa. Let's see how the graph shifts when c changes. If c equals to 10 and b equals to 0, the graph will shift 10 units upwards from the original y equals to j graph. If c equals to 5 and b equals to 0, the graph will shift 5 units upwards from the original y equals j graph. Thus, when c decreases, the graph will shift downwards, and when c increases, the graph will shift upwards. I will use the previous examples to explain the reason for the shift. I is similar nature to 1 in y equals x to the power 2 plus 1. In conclusion, changing b will cause the graph to shift along the vertical and the horizontal axis, but changing c will only cause the graph to shift along the vertical axis. Last but not least, I will explain the changes in solution for different discriminant values. The formula to find the discriminant value is b to the power 2 minus 4ac. The values of a, b, and c correspond to the values in ax to the power 2 plus bx plus c. When b increases, b to the power 2 minus 4ac will also increase, and vice versa. Also, when c increases, b to the power 2 minus 4ac will decrease, and vice versa. In conclusion, when b is increased or when c is decreased, the discriminant value will increase. However, when b is decreased or when c is increased, the discriminant value will decrease. Thanks for listening.